and they could run successfully. You could see that this is the confusion matrix for the third data set, and you could see that we got accuracy like 4.8%, and the balance accuracy like the 2.7%. We don't get a good amount of specificity and sensitivity as well. So I could say this model doesn't fits well in this third data set. And let's go with and this for second data set, and we've got a significant amount, and we got 17%, and it predicted like 62 plus 171, and it mispredicted like 185 something, and it's 63. So this model not worked very well, but it worked well. It's, this model worked well on the second data set, knowledge distribution. And this is for a first model, and we got a good amount of accuracy. So and we got a good amount of balance accuracy and sensitivity specificity. So this model worked very well on this data set, but we didn't got a good amount of sensitivity. It's good, but not a better one. Actually, say with sensitivity and specificity, it's these two things are most important, because with sensitivity you could able to identify the positive value, or it could in prediction on in predicting the positive value, and instead specificity we could able to identify that how the model is good at prediction of the negative values. So here, the positive values we mentioned as one. In the statistics world, the one is a good one, but in the real world, we have this one as fraudulent activities. We have given as one. So if it is one, so if it able to predict once, so we could able to predict the fraudulent transaction in credit card. So with this, we could able to handle this kind of transactions, and we can block them. Okay, with this pattern we could able to identify the credit card transaction, the credit card fraudulent transaction, and we could able to block them. So and the code has run successfully, and it takes a long time, so I'm just editing this video for the purpose. And accuracy, we got a very good amount of accuracy over here, 99%, and sensitivity is 197, 99%. So I could say this is a really good model. This fits very well in this model. So this is good actually. And this is good as well. And SVM 10 is good job with this dataset as well. And here also we got a very good result. And SVM done a very good job on this dataset as well. We got a good amount of accuracy, sensitivity, and but specificity is not that good. So it poor in predicting the negative values. But still it's fine, because the as per our requirement, uh, the model which predicts positive value, it's actually needed, because we need the pattern for the positive value to avoid a click or fraudulent transaction. So it is good, even though it got very less specificity. So this model is good, and we just run the third model, and it ran successfully. And here we got, oh my god, it's a very good result. Random forest one, random forest model for the third data set has predicted 100%. Actually, this is the, you could say easily, this is the best ever model. Random forest, I could say best ever model, because why this best? Why it's very good? Actually, it in average, if you take, I've already done in this report. So I'm just telling that you could say in average this works the best in every data set when compared to other models. Is this because it's statistics, because it's not sensitive to missing values and outliers. It just takes whatever the important it feels important. So, due to this characteristics of the random forest, it works very well with every data set when compared to other models. And this the graph, which is the random forest. Actually, random forest will rank the variables when features according to the how important it is. Let me show this thing. So here we got this. So the most extreme one, so loan condition, which is the most important one, and it's our target variable over here. And over here, V17 is the most important feature of this dataset, and page 0 is the most important feature of this dataset. The final model KNN. We're just going to run the KNN of the final model. You could see, actually, we didn't got good result. And though we got good accuracy, we didn't got good sensitivity, which is the important one. So this model doesn't fit very well with dataset 3, and same with dataset 2, and same with dataset 1. Zero sensitivity. So this is not good. So I could say, comparing to other models, this is the worst model, because it fails actually. This is the failing model. I'm choosing this as a failing model because it predicts all. It's the prediction of the sensitivity, the accuracy of the prediction of the sensitivity is not at all good for any data sets. So when compared to other models, and there is a reason for this actually, why KNN fails on this statistics, because KNN is not good for the categorical variables. Okay, and all of the category target variables are categorical, so it fails when it comes to target variable. It doesn't perform well when we have a categorical variable. That is the disadvantages, one of the disadvantages, and it's that model characteristics. So due to this, uh, to come to the conclusion, I could say random forest is the best model, and when compared to overall models, compared to other models, overall random forest performed very well on the three assets, and KNN doesn't perform doesn't perform very well. Actually, KNN is the worst model, and it fails on every data set by predicting the very low level of sensitivity, which is most important for the sake of making the business decision. Actually, with the sensitivity alone, we could be able to predict. Actually, we need is just sensitivity. How accurate the model is predicting the sensitivity. So with this, we could able to avoid the fraudulent activities, financial activities like bank loan default and credit default and the credit card fraud transactions. So what we need is overall is sensitivity accuracy. So when comparing the sensitivity what we got for the each of the model, we could say random forest perform very well and this is the best model, and KNN doesn't perform well, and KNN is the worst model because it predicts a very low level of sensitivity. So this as I said before, this is because of the characteristics. So I finished. That's all, Fox. Thank you.